I'm happy to present you today the new feature of eVision 24.6. We have a major milestone, which is the Python bindings for eVision. Python, the language, is very popular, especially amongst mathematicians and engineers, because you have a very intuitive syntax and a very large, huge ecosystem of packages. It allows usually very high-speed and fast programming. It's clearly the reference language for academic publication and especially computer vision. And what is covered by the new Python bindings of eVision? Basically everything. All current features of eVision, like pattern matching, measurements, code readers, 3D, deep learning, are included in the Python bindings. And also all platforms that we currently support in eVision are supported by Python, Windows, Linux, and Linux ARM, which is, of course, very popular on embedded systems. The only requirement here is to run the Python bindings with Python version 3.11 or higher. So it may require some extra installation on some old Linux distribution. We also take care of a specific focus on allowing fast byte exchange for images. We heavily test Python bindings with eGrabber, NumPy, OpenCV, or other image packages. So it should work very fine and very fast with most computer vision related libraries, and also it's fully compatible with Jupyter notebooks. Now I will let Nicolas present you some live demonstration of Python in action.
So in this example, I will use an example development environment for Python. Here I use Visual Studio Code. And the first thing I need to do in my main Python file is to import eVision. Then for this specific example, I will also use another Python module, which is EasyDeepLearning, because this demonstration will use EasyDeepLearning. So to use EasyDeepLearning, I will first create a classifier where I will store in a variable name classifier. So I will instantiate eVision EasyDeepLearning.eClassifier. And in order to load an existing classifier that I have here, I will use the load method. So as you can see, for all classes and methods, I have full integrated documentation with documentation of all overloads. Here I will just use the first overload, which is a file path, which is a string. So I will copy paste the name of my classifier. Then in order to test this classifier, I need to load a test image, which I can do by defining a variable named image. Then I will instantiate an eVision eImage C24, and I will load that image from the file system using load, and then I will load this image. I will show you this image. This is one of our test image used with the mini waffles model for EasyDeepLearning that we provide as part of our test resources. Then to attempt classification on this image, I will use the classify method on the classifier on the image. As a reminder, the classify method returns an eClassification result. That's convenient to see in the documentation. And then I can print the result by using the best label property on the result. And now I can launch my script using Python main.py. And here I see that the label for this image is correctly detected. This is indeed a good image. Now I switch to another version of this test script, which is a little bit more complete, Here I added some details, notably argument parsing, to be able to pass the name of the image I want to use using the command line. I make some setup in order to activate GPU acceleration for EasyClassifier. I make also some measurement of processing time to be able to display it. And then I have rendering code here in order to be able to create a display image for my classification result. The display image will contain a heat map if the detected image is of bad quality. I will also print some additional information, notably the label, the probability detected by EasyDeepLearning, the processing time, and I will perform a display using a library known as matplotlib. Now I will use my script using the NW bad image, which is this image, which is a bad image. And here is the result of the execution of my script. I can see that the heat map indicates some problems in this image. It is correctly detected as a bad type of image. The probability is 99% and the processing time was around 5 milliseconds.
We have seen a coding session of Python for eVision by Nicolas, and now maybe another demonstration?
Yes, Christophe, no problem. So for this second demonstration, we have some setup here. First, we have some lighting, we have a camera, we have a turning table with some QR codes, and we have a Raspberry Pi. So this Raspberry Pi runs little Python programs, and it performs this way. First, it will read the image from the camera using libcamera. That's Raspberry Pi specific Python library to read images from camera. Then it will perform some processing to read and detect the QR codes here using OpenEvision's EasyQRCode through the Python bindings for OpenEvision. And it will pass the result to a small web server made with Python async.io and IOHTTP. And this web server allows to propagate the result to any remote device which is connected using the network. So as example, here we have a laptop computer running Chrome, basically. It is connected to the Raspberry Pi using HTTP. And as you can see, we have the preview image of the camera. We can see the location of the detected codes. And we also see here in the bottom the code which is read. I will alter the scene a bit so you can see this is indeed a live preview. And we also have here a smartphone which displays the same result.
Okay, but what about the performances? Because Raspberry Pi is not a very powerful platform.
Well, the way the Python bindings for OpenEvision work is that they just form some kind of thin layer above C++ code. So whenever you call a method in OpenEvision to the Python bindings, it's just C++ code that will perform the operation. And that C++ code is the usual OpenEvision C++ code, which is optimized for the platform, so for ARM64 in this case. This kind of combination of both C++ for performance and Python as a high-level language with a good ecosystem of library, in the end, I think it's kind of a good combination.
Oh, nice. And it's a very interesting demonstration. Is that sample code included in OpenEvision?
Yes, this demonstration is included in the installer of OpenEvision, like a lot of other samples that are made for the team, by the team, in order to simplify as much as possible a new Python project for users.
Thank you, Nicolas, for these interesting demonstrations. But there is more. We have a lot of Python samples in the OpenEvision distribution. console samples. So console samples run on the command line interface, like image processing samples, matching and measurement, text and code reading, and also, of course, deep learning inspection. And also, we include some live camera sample in the distribution for OpenCV camera, using eGrabber from Euresys and using Allied Vision Vimba X SDK. So these samples are, of course, the starting point for you to play with and build your own application using eVision components. We have also a sample for a 3D viewer, which show how to display point cloud or meshes live on the Python application. And finally, we include a graphical user interface using Qt for pattern matching using EasyFine and measurements with EasyGauge. And an important point that we have to deprecate some feature of eVision, some method and classes, because the Python compatibility does not allow everything we can do in C++ and C#. So some of method has been deprecated. But what does it mean? It means that deprecated methods are not recommended anymore for new development. Of course, deprecated method will stay available in eVision 24.6 and later. So your old application, your current application that use this function will compile and run without any problem. And most deprecated methods are being replaced by new ones. Python bindings for eVision include in the general eVision distribution like the C++ and C# wrapper at no additional cost. So there is no specific price for the Python compatibility. And it's already available on eVision 24.6, which is on our download website. We will introduce EasyDeepOCR, which is a major evolution over the EasyOCR and EasyOCR2 products. We still target industrial marking, but we really would like something which is easy to use and works out of the box. We spent a lot of time focusing on read capability, so the ability to read difficult text, and speed. But how EasyDeepOCR compare with the previous version of OCR in eVision? The oldest product, EasyOCR, has some advantages. It can be trainable using sample user images. It works with conventional classifier for industrial fonts and is basically really fast. But you have some strong limitations. First, it can read only horizontal text. And the segmentation, so the way to separate the text from the background, is really basic. EasyOCR2 move forward for the segmentation, so have an advanced segmentation and support text rotation, and also some pre-trained deep learning industrial text classifier. But it's somehow difficult to configure with a lot of parameters has to be set up. EasyOCR lately is a deep learning based OCR. It's really simple usage and works out of the box, as we will demonstrate later. You can use a text topology to select the text you want to read, and there is a learning process to speed up the processing of EasyDeepOCR. We basically define three different scenarios for EasyDeepOCR. The first one is the simplest one. It's just that read image or region of interest without any configuration or learning. So if I have the image on the right here, with some text, a very simple image. The very basic code at the left here show how to load an image, instantiate a new deep OCR, and then call read. And with this simple program, we are able to read all the text in the image without any distinction. That's the first scenario. The second scenario is to use a topology. So most of the time, you are not interested by all the text in the picture. We usually focus on some interesting codes, serial numbers, expiration date, or stuff like that. And most of the time, these texts have very well-defined topology format. So by given topology to OCR, we are able to only read the text that match these topologies. Right? In the example on the right, you see using the topology 2-digit, a point, 2-digit, a point, and then 4-digit, just read the 2 expiration dates here. That's the second scenario, and it's especially interesting if your texts are not at the same place over the picture. Otherwise, you can set up a region of interest, but if the text changes in the position or orientation, is a useful feature to just read the code you want to read. And the third scenario is to use a learning capability of EasyDeepOCR to make the processing pipeline faster, optimized for your specific context. So it's not like training in deep learning. We will not train using a lot of images and stuff like that. It's optimize the processing pipeline of EasyOCR to have the fastest read possible. In that example, again, if we read without any topology or learning, the reading time is about 600 milliseconds. If I use a topology, like the step before, it's down to 250 milliseconds. So it's faster, but not that fast. If I use 2 images first for learning, so the 2 images at the top of the screen here, then the reading time get down to 44 milliseconds. So it's a lot faster. And how we do learning? By simply give the picture and give the text in the picture we want to read. So now we'll get a little bit deeper with Xavier that will show you some demonstration of EasyDeepOCR in action.
Thank you, Christophe, for the nice introduction. I'm looking forward to demonstrate the capabilities of our new EasyDeepOCR. So for today's demonstration, we will be working with a delivery slip like this one. We choose this context because it features many different texts of various sizes that will enable us to demonstrate the great features of EasyDeepOCR. So today we will also be working inside the demonstration sample that we are developing together with EasyDeepOCR, and that will be released at the same time than EasyDeepOCR. So the first use case of EasyDeepOCR is quite straightforward, as you mentioned in your presentation, Christophe. So you just have to open an image. So here I'm opening an image of a delivery slip like this one, and then press read. And as you can see, all the text in the image are detected and read without setting any parameter.
Nice, but usually we just need some selected text in the whole picture.
Yes, that's true. It's a frequent use case that you don't want all the text in the image, but only selected text in the image. And that's why we introduced the concept of topologies to select the text that you want. The topology is simply the format of the text. It specifies the type of each character. So in this case, if you want to read this expedition number, for example, what you only need to do is to specify the topology of this number, which is composed of 8 digits. So the topology for a serial number of 8 digits is simply 8 times 0, because 0 stands for any digits. So if you add this topology to the list and then read again, then you can see that the reader only outputs the text composed of 8 digits, which is the expedition number that you want. And you can add many other topology to the list. For example, if you want to read this expedition date, then you just have to add the topology of a date, which is 2 zeros, which stands for the date, then a slash, which is inserted between square brackets because we know there will always be a slash there, then 2 digits for the month, then again a slash, and finally 4 digits, which stands for the year. And we can add a third topology, for example, this serial number. This number always starts with a T, so its topology is a T between square brackets because it's always there. And then 6 digits for the code after the T. So 1, 2, 3, 4, 5, 6 zeros. Now we have 3 topologies in the list, and if we read again, then you can see that the reader only outputs the three texts that match one of the topologies in the list. Specifying the topology is a very powerful tool because it enables the reader to discard any irrelevant text and to focus only on the text that you are seeking.
Nice. Can you zoom in a little bit on the results?
Yes, of course.
Yeah, thanks. So now we have selected the text we would like to read in the picture. Is there a way to speed up the whole process?
Yes, of course. In EasyDeepOCR, we added the ability to specialize the reader to detect a given kind of text in a given context. So, for example, imagine that we only want to focus in this kind of text, the one that starts with T. So I will remove the other two topologies and only keep the one corresponding to this kind of text, and set the maximum number of text to read to 1. If I try to read with no further information, then you can see that the processing speed is around 500 milliseconds. Now I'm going to show you how you can specialize the reader to be very efficient to read this kind of text in the delivery slip. To specialize EasyDeepOCR, it's rather easy. You only have to provide to the reader example images. So here I opened a new window that I will use to provide the sample to EasyDeepOCR. In the context of EasyDeepOCR, a sample is simply an image together with the text that you would want to read in that image. So let me add a first example. So here I'm selecting an image from another delivery slip, which is very similar, but which is not the same as the original one, of course. So in this image, the text that we would want to read is this one. So it's T889647. Okay, that's it for our first example. Now let's add one more. So again, I take another delivery slip. It's the same context, but it's not the same delivery slip. And here the text that I would want to read is simply T456327. Okay, one more example. So let's take a last example, a last image. So in this image, the text we would want to read is T741123. Okay, now that I have my list of 3 examples, I can start to specialize the reader to read this kind of text. So I simply click Learn. It's important to highlight here that it's not a training. The only thing that gets done when you specialize the reader is to optimize the processing pipeline to be as fast as possible to read this kind of text that starts with T. So now the learning has been performed and we can try to read again. So if you remembered, without this learning, the processing speed was around 500 milliseconds. And now, with the learning, if I try to read again, then you can see that the processing speed is around 100 milliseconds, which is much faster. And now that the setup of EasyDeepOCR is done, we can see it running in live action. So now I'm going to open the image from the camera, from this camera, and link it with the EasyDeepOCR I've just set up. So in addition, I put a timeout so that the camera doesn't freeze when there is no text. And I open the camera. So as you can see, the camera is running. And if I put my delivery slip under the camera, well, the text that we wanted to find is indeed found, and no other text is detected. And you can move it around, and you see that it still works. So in conclusion, EasyDeepOCR is a general purpose reader, but you can specialize to many industrial vision applications, and that's really my favorite feature about it.
Thank you, Xavier. Of course, it's not limited to delivery slip. There is a lot of different contexts that can be addressed with EasyDeepOCR. For example, here we have a tire marking example, also an expiration date on the food product, some dotted text on also, I think, a product, again, dotted text on a package, some expiration date and lot number on the pharmaceutical blister pack. And finally, here, a very specific font used for wafer marking. What is the requirements for EasyDeepOCR? Like any other OpenEVision feature, it runs on Windows and Linux, Linux Intel CPU or ARM CPU. And we really focus on the fast CPU processing. And it is possible thanks to the Intel OpenVINO SDK, because we know that for OCR and for industrial application, maybe users don't want to use GPU in their embedded system or PC. But of course, it can be even faster if you have a GPU for inference. EasyDeepOCR is not in OpenEVision 24.6, but will be in the next release, which is OpenEVision 24.10. So it's the October release of OpenEVision. There is already a beta version of EasyDeepOCR. So if you have new OCR project that seems suitable for EasyDeepOCR, please let us know, and we can send you a beta version for testing and evaluation. That's all about EasyDeepOCR. And now I will speak sometimes talking about the other improvements we have in OpenEVision 24.6. We have some requests to introduce a Fourier image class, which is a way to help the usage of Fourier transform. We had the Fourier transformation in OpenEVision some times ago, but now with the eFourier image, you can easily query the results to get different modality, different images in the frequency domain. So it really helps if you would like to use the Fourier transformation, for example, here to remove periodic noise in images. We also introduce some new samples in OpenEVision, samples using the Windows Presentation Foundation SDK. So it's a specific SDK for Windows, and these samples show how to use the display capability of OpenEVision in WPF with a basic sample and a more complex 3D sample. We also spend some time optimizing EasyMatch. EasyMatch is one of the libraries for pattern matching, and now EasyMatch is up to 1.5 times faster, so 50% faster than the previous version of OpenEVision. It's especially visible if you search for multiple instances with scale and rotation. We also introduce improvements for EasyMatrixCode 2. EasyMatrixCode 2 is now in average faster to read data matrix. And also we improve the ability to read codes with some degradation in the codes. So if the code is not fully correct, if there is some pollution on the codes. So it's better reading capabilities on some images. And finally, also, we improve the way the documentation is available in the IDE. So when you develop with OpenEVision using your favorite IDE, you can now get code completion. So it's show you all possible method, classes, namespace, members you can access with OpenEVision, but also, and that's very interesting, documentation for all these methods. So in Visual Studio Code or, for example, Microsoft Visual Studio, you get inline reference documentation for all OpenEVision methods. Now it's time to conclude. So in summary, in doing this presentation, I show you the usage of Pythons for OpenEVision. That will hopefully open some new usage for OpenEVision. I also spend some time explaining the new Deep OCR for OpenEVision that will be released in OpenEVision 24.10. And finally, as always, there is multiple improvements in the other library of OpenEVision like code reader or pattern matching. So now I think we could take some of your questions.